All right, let's try some further practice of these related rates. Now, in the previous examples, we were looking at how geometric shapes were changing over time, or measurements of geometric shapes were changing over time. In this case, we're going to take a look at how it applies to motion. So, the big thing here is we still need to be able to draw a sketch of what it looks like, turn it into two-dimensional or three-dimensional shapes where we can take a look at what's happening over those planes and be able to create our equations based on that. So for example 1, it says a 2-meter tall man walks away from a lamppost whose light is 5 meters above the ground if he walks at a speed of 1.5 meters per second. At which rate is the shadow growing when he is 10 meters from the lamppost? All right, so let's see what we have here. So first off, we have a lamppost shining a light. We have a man, and he's obviously walking away from this lamppost. And what happens is the beams of light are going to come from the lamppost, hit the man's head, and extend it off until it hits the ground. We also have that horizontal plane between the base of the lamppost, where the man is walking, and where the shadow ends. And we know, given what it said, that this lamppost is 5 meters tall. We know the man is 2 meters tall. And we have two distances that are changing that is related to this problem. We have the distance the man is from the lamppost, and we have the length of the man's shadow. So with those two lengths that are changing, I'm going to call them x and y. We also know that as he's walking away from it, x is increasing in this direction, and y, the length of that shadow, is also going to increase as he is walking away. So we're going to define our variables. We're going to say let x equal the distance from base of lamppost to the man. Let y represent the length of the shadow, and let t represent time in seconds. And we can tell that from our units here. Then we're going to say, what do we know? Well, we know that dx over dt, the rate that he is walking away from the lamppost, is 1.5 meters per second. And we're trying to solve dy over dt. Well, I have two related triangles here, and they're both right-angled triangles. Here's a right-angle triangle, and here's a right-angle triangle. And because this angle is staying the same, and we're stretching it out, then the relation between this and this has to be the same as the relation between this and this. Which means that we know that the opposite, 5 divided by the adjacent, which is x plus y, has to equal the opposite of the smaller triangle, 2, divided by the adjacent, which in this case is just y. Well, when I multiply that x plus y and y out of there, I get 5y is equal to 2x plus 2y. I'm going to move the y's to one side, and so I'm going to get 3y is equal to 2x. And if you wanted to, you could divide both sides by 3 at this point, or you can just differentiate, which is what I'm going to do. I'm going to say that 3 dy over dt is equal to 2 dx over dt. Well, I know what dx over dt is. So 3 dy over dt is going to equal 2 times 1.5. I'm going to divide both sides by 3. dy over dt is going to equal, well, 2 times 1.5 is 3. I'm going to divide that by 3, and I'm going to get 1. And then we know that the rate that this is changing at is in meters per second. And then we're going to write our sentence. Therefore, when the man is 10 meters from the lamppost, the shadow is growing at a rate of 1 meter per second. For the second part, when it says determine how fast the tip of the shadow is moving along the ground. Well, remembering the triangles we built, we have our lamppost, we have our man, this is still 5, this is still 2, and we said that this is x and this is y. What's happening? Well, we know that this x is increasing at 1.5 meters per second. We know that this y is increasing at 1 meter per second, which means that if this length is growing at that rate and this length is growing at that rate, and this is the tip of the shadow, then this tip of the shadow is stretching out at a combined rate of t. Well, both the x and the y are increasing, and the x and the y make up t. So if that t is equal to x plus y, then that means that the speed at which t is growing over time has to equal the speed at which x is growing over time plus the speed at which y is growing over time. Well, then that's going to give me 1.5 plus 1, which is 2.5 meters per second. Therefore, the tip is, of the shadow, I should state, is moving at a rate of 2.5 meters per second.